Fractional-N frequency synthesizers are notorious for producing unwanted spurious frequency components called spurious tones or spurs. The causes of spurs that are fixed in frequency are well known. Unexplained moving spurs and pulsating noise floors have also been reported in Fractional-N synthesizers. When examined with a spectrogram, such dynamic phenomena can be readily explained as manifestations of wandering spurs. Frequency synthesizer chips, such as those made by Analog Devices and Texas Instruments, contain a controlled oscillator that produces the user-defined output frequency. A frequency divider in the feedback path of a phase-lock loop sets the output frequency to a precise multiple of an accurate reference frequency. The quality of the output signal can be visualized in the frequency domain. A clean spectrum, corresponding to a pure tone, has its energy concentrated at a single frequency. Fractional-N frequency synthesizers usually exhibit additional unwanted frequency components. These are called spurs. Fixed spurs are caused by the reference clock and the divider controller. Fractional-N synthesizers can also exhibit spurs that are not fixed in frequency but move about in the spectrum. When viewed with a conventional swept spectrum analyzer, so-called wandering spurs appear in different ways. One might see a few moving or travelling spurs, a large number of walking spurs, or a pulsating noise floor. With peak hold on, randomly placed individual spurs can fill out the spectrum. Wandering spurs are caused by a double accumulation of a constant in the divider controller. The frequency at which they occur and the speed at which they move can be predicted. When visualized using a spectrogram, wandering spurs have a well-defined structure. Plotted with a real-time spectrum analyzer, one can see that the pulsating spectrum is caused by randomly placed spurs that are symmetric about the carrier. The spectrogram, shown on the bottom half of the screen, is a top-down view of the spectrum with its amplitude color-coded. Red is high, blue is low. Time runs along the vertical axis. In the spectrogram, the carrier, which is fixed in frequency, appears as a vertical line. Wandering spurs, which move towards and away from the carrier, appear as two V's that meet at their tips. As time advances, the two wandering spurs move linearly in frequency towards the tip of the V at the carrier and then away from it. This gives the wandering spur spectrogram its characteristic tip-to-tip V shape. The next time you see walking, marching, travelling spurs or a fluctuating noise floor, think about wandering spurs and make sure to plot a spectrogram. To learn more about wandering spurs, how they arise and how to get rid of them, see our recent publications.